so this starts our sequences in series. So let's just jump in and look straight at an example. And this will kind of set the stage for the several videos to come. Example 1. Find the first 4 terms of the sequence. Alright, and here's part A. Now this is going to be labeled a little differently than what we're used to seeing. We're used to seeing f of x, but here it's going to be labeled a sub n. So it's a big A with a little n below it. And then it's basically the same as f of x. Our function is called a now, and n is the number that we're going to plug into our equation over here. And let's call it 3n squared minus 4. And all I want to do is find the first 4 terms of this. And you start just by plugging in 1, then 2, then 3, and then 4. And then those are our first 4 terms. So let's find A1, or A sub 1. That means we're plugging in 1 into the A everywhere. Everywhere there's an n. So this becomes a 1, and this becomes a 1. So you get 3 times 1 squared minus 4. That's equal to 3 minus 4, which is negative 1. And then let's move on to A2. That means we're plugging 2 in here for n. 3 times 2 squared minus 4. So that gets me 3 times 2 squared, which is 4, and then minus 4. So that's 12 minus 4, which is 8. Alright, now try A3 by yourself. Pause the video and give it a try. What this is saying is that we take 3 and we plug it into here everywhere there's an n. So we get 3 times 3 squared minus 4. That's equal to 3 times 9 minus 4. 3 times 9 is 27. 27 minus 4 is 23. And then the last one, A4, go ahead and give this one a try. 3 times 4 squared minus 4 is equal to 3 times 4 squared, which is 16, minus 4. And that's equal to 44. Alright, hopefully that's not too bad. What this is doing is it's getting your mind and it's getting you in the right mindset for the next couple videos to come. Let's look at one more here. Part B. Let's call this one C sub n. So now I'm just calling it C, and our subscript, that's what we're plugging into. Alright, so let's try 9 times negative 1/3 to the n power. Alright, you pause the video and try to do all 4 by yourself, and then come back and see what I'm working with. C1 means we plug 1 in here for n. So you get 9 times negative 1/3 to the first power, which is 9 times negative 1/3, which is negative 3. C2, 9 times negative 1/3 squared, which means it's 9, and then negative 1/3 squared means you're multiplying by negative 1/3 twice. So a negative times a negative is a positive. 1/3 times 1/3 is 1/9, which is equal to 1. C3, that means we're plugging 3 in here for n. 9 times negative 1/3 cubed. So that's 9 times negative 1/3 cubed means we have 3 negatives, so the negative is going to stay. And then 1 cubed is 1, 3 cubed is 27. then that's equal to negative 1/3. Last one, C4, 9 times negative 1/3 to the 4th power. That's equal to 9 times negative 1. 1 to the 4th is 1, divided by 3 to the 4th, which is 81. And that's equal to, oh, I messed up. See, you got to be careful here with these negatives. That negative doesn't exist because we have this even exponent. So we have 4 negatives, you multiply 4 negatives times each other, it becomes positive. So you get 9 over 81, which is 1/9. Alright, hopefully you can see the pattern there. And this is all to get you in the right mindset for the next couple of things to come. Alright, let's look at one more example here. Example 2. Write the first 4 terms of the recursive sequence, which this is a new term here you may have not seen, recursive sequence, with A1 equal to 4 and A sub n equal to 2 times an minus 1 plus 1. So what this is telling you is that your first term is 4. That's already given to you. And then this is a recursive sequence. The reason it's a recursive sequence is because to find the current term that you're on, an, you have to know the previous term, an minus 1. So that's why a1 is given to us. So recursive means you have to use the previous terms to find the current or the next terms. All right, let's look at how to find this. So A1, that's easy, that's 4. I encourage you to pause and try this, and then come back and see how I'm doing. A2, so that means we're taking 2 and going to plug it in here for n. So that means 2, then times A sub 2 minus 1, and then a big plus 1 on the outside. So we get to 2, A sub 2 minus 1. Over here we had 2, A sub n minus 1, so that's where this comes from. And then all of that you add 1 to when you're finished. Okay, that's equal to 2 times A, and then just do the subtraction here. 2 minus 1 is 1 plus 1 on the outside. Alright, the next thing is, this 2 is here. Do we know what A1 is? Yes, it's the previous term. It was given to us. So that's what we plug in here. And then we have to add 1 to all of that. Then that's equal to 8 plus 1, which is 9. Alright, let's try A2. A3. So that means we're plugging 3 in here for n. So you get 2 times A sub 3 minus 1, and then you have to add 1 to all of that. Keep simplifying, you get 2 times A sub 2, just doing the simple subtraction there, then I'm adding 1 to all of that still. This is equal to 2 times A2. Do we know what A2 is? Yes, we just found it over here. It's 9. So that's what we're plugging in here. And add 1 to all of that. So that's 18 plus 1, which is 19. And then last one, A4. That means we're plugging 4 in here for n. 2 times A sub 4 minus 1, and then all of that plus 1. That's equal to 2 times A sub 3 plus 1, which is equal to 2 times A3, which we just found to be 19, plus 1. So this is 38 plus 1, which is 39. So that's how a recursive sequence works. See you in the next video.